up, athletes? Whoop, whoop. All right, let's do this today. We're talking about slope. Go ahead and write down that today is day 2. So in your notes, it should be like 4.2 day 2 in whatever the date is. And we're going to talk about slope, which is essentially rate of change. But let's talk about this. So this says you can use the sketch to investigate the slope of the line, blah, blah, blah. Okay, slope is rise over run. So if I'm looking at my right mouse that works, got to turn it on. I got a wireless mouse here. What? Okay, so you notice we have our rise right here and our run. Line, just trying to get out of the way. So our rise over our run. So you'll notice this is a very shallow slope. Our rise is 2, our run is 10, so 2 divided by 10 is 0.2, and that gets me my slope. That is my rate of change. Rate of change and slope, same exact thing. That means I go over, or I go up 0.2 every time I go over 1. Or an extreme example could be I go up 2 and over 10. All right, and this can change. So if I keep letting the line just rotate itself, notice that as my rise is increasing, my run is decreasing, and my slope is increasing. Watch what happens. It's going to start to get very big very quickly soon. Okay? There we go. Now we're starting to see some things. Now notice I have a rise of 9, and I have a run of 3. So that means I go up 9, see up, 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3. And when I do that, 9 divided by 3 is 3. I have a slope of 3. Okay? So that means if I were sitting right here at the origin, I could go up 1, 2, 3, and over 1, and boom, look, I'm right on the line. I could go from here up 1, 2, 3, go over 1, I'm on the line. That's what it means to have a slope of 3. Now let's look at horizontal and vertical slope. We've talked about them, but let's go ahead and make this horizontal. By the way, notice, real quick, as our slope began to go down from left to right, then guess what happens? That's right, it becomes negative. But let's go and make it horizontal. So what's going to happen when it's horizontal? We've talked about this, but this animates it and lets you see it a little easier. Look at the rise. When it's horizontal, there's a 0 rise. You notice a 0. There is a run we have right here between these 2 points of negative 10, but it could be infinity. It doesn't really matter. What's 0 over anything? 0. But then let's look at when it's vertical. Now notice my run is starting to disappear, but my rise, that's getting bigger. Okay? Now, my rise is huge, but my run is 0. Notice there's no slope. It's because this would be 10 divided by 0, and you can't have division by 0, so there is no slope for a vertical line. Wrong button. Awesome. So that's just kind of an exploring, looking at slope. Now we're going to talk a little bit more about it. Our slope is, again, our rise over our run. So let me control plus. Is that the thing? Make it a little bigger. There we go. Okay, the slope of the line is the rate of change of the y coordinates rise for the corresponding change in x coordinates run. So it's the same as rate of change. It's rise over run. It's your change in y over change in x. In this case, if I pick 2 points, notice what I can do. I'm just going to take my y values. So I've got 1 and negative 3, and I'm going to write, in this case, negative 3 minus 1 over, and then I'm going to take my 3 and my negative 2 over 3 minus negative 2. So what I've done is I've got negative 3 minus 1. I know you see it there, but it's a little small. And I also have 3 minus a negative 2. Now what can I do with a minus negative? That becomes a plus. So negative 3 minus 1 is negative 4. And 3 plus 2 is 5. So what is my slope? My slope is negative 4/5. That tells me I should be able to go down 4 and over 5. Let's try it. Down 1, 2, 3, 4, and over 1, 2, 3, 4, 5. Keep in mind, when you have negatives, that means you go down instead of up, but you always go to the right for the run. Okay? Awesome. Sorry, wrong button. Now we're going to talk about positive slope. So I want to look at this right here. Let's look at it. So without even paying attention to these, let's just look at the grid marks. Let's do this. I'm going up 1, 2, 3. So that's 3 up. And I'm going to the right 1, 2, 3, 4. That is a rise of 3, a run of 4. And remember, it's rise over run, or change in y over change in x. So that equals 3 over 4. And that's a positive slope. And we know that because from left to right, we read it like we read a book, is going up. It's going up. Okay? So this is a positive slope. Now, you're going to see a slope formula. I'm going to explain it. This is your slope formula right here. What it says is that first of all, our slope, let me go ahead and erase this. Write this down, pause if you need to, but I'm going to erase this. Our slope is equal, we call it our m. It's our m value. So m is the variable we use for slope. And that's equal to our change in y over change in x. And what is our change in y? That's really just taking my y2 and so my first y value and subtracting, or my second y value and subtracting my first y value. I'm going to divide that by taking my second x value and subtracting my first x value. Now what does that mean? Well, look at these 2 points right there. If I were to call this x1, y1, and I were to call this point x2 and y2. And I could have switched. I could have done this the second point and negative 3, 4 the first point, but I didn't. So let's do this. If I'm going to do my y2 minus y1, I'm going to have 4 minus 7, right? All over my x2 of negative 3 minus my x1 of 1. And what do I get? I get 4 minus 7 is negative 3. And negative 3 minus 1 is negative 4. And what are two negatives? They make a positive. When I do a negative divided by a negative, that's a positive. So this is positive 3/4, which is what we got the first time using the formula y2 minus y1 over x2 minus x1. Although you will honestly never see me actually label these in real life when I'm doing it. How I do it is I really just take one of the y values, circle it, and say, all right, let's subtract the other one. And then I go back to my x value and subtract it. Okay? As long as whatever one you start with the same one on the x, you'll be fine. Okay, let's go ahead and move on. Let's look at negative slope. Now, if positive slope is going up from left to right, a negative slope is going down from left to right. So negative slope is going down from left to right. Okay, let's look at this. How much did it go down? We see it's going down, so that's it. Going down how many? 1, 2, so I'm going to write negative 2, and it's going over how many? 1, 2, 3, 4, 5. So what's my slope? My slope is negative 2/5. Remember that negative goes out front or up in the top, never in the denominator. Okay. I could also do this using the formula. I would just simply have 3 minus 1 all over negative 1 minus 4, which is 2 over negative 5, or negative 2/5. Yeah, negative slope. Write it down, pause if you need to. Let's go. And we just got done talking about this. Slopes of horizontal lines is simply going to be 0. And I can do that mathematically. Let's do it. So, I didn't mean to do that. So I'm going to have -5 minus -5. So -5 minus -5 all over 4 minus 2. 4 minus -2. So again, both are going to turn into a plus. This will turn into a plus. And I'm left with -5 plus 5 equals 0. And 4 plus 2 is 6. Really, the denominator doesn't matter because we're going to have 0 over 6, which is 0 to 0 slope. Okay? All horizontal lines have a 0 slope. And we see that down here is just a nice horizontal line at y equals -5. Now, with that said, it slopes of a vertical line has no slope because we're going to have division by 0. Watch what I mean. Okay, let's do our subtraction. -2 minus 4 over -3 minus -3. So -3 minus a -3. This is going to turn into a plus. -2 minus 4 is -6 up top, but we don't care. Why? Because on bottom, -3 plus 3 is 0. Division by 0 is muy bad. Turns into fire. All right, you get the point. Okay? Now, how can we use the slope to help us? Well, let's find out. What is that doing? Okay. Sorry, I was doing something. All right, so I can use the slope formula to help me because I can use this and go, all right, so I'm going to have r minus 5 all over 4 minus -4. Equals 3/4. All right, so this is going to turn into a plus, and I'm going to end up with, better write a little bit better, r minus 5 over 8 equals 3/4. Now watch this little magic. I want to get rid of this 8, so I'm going to multiply the whole thing by 8, because that's divided by 8, right? So that's going to cancel this out. And I need to multiply this side by 8 as well, which 4 goes into 4 once, it goes into 8 twice. So now, what am I left with? I'm left with r minus 5 equals 6, because 2 times 3 is 6. Okay, let's add 5 to both sides. And I get that my r equals 11. So, given the point -4, 5 and a slope of 3/4, I will have a point on the line for 11. Okay? All right. Let's go on to the next one. Okay, same problem. Take a minute, try it out, pause me, and then we'll get back and we'll do it together as a class. Ready, set, go. Okay, let's come back and do it. So again, I'm going to have 5 minus -3. All over r minus 10 equals -4. Excuse me. All right. So this one's going to be a little different, so just hang with me on this, because as long as I do the same thing to one side, I can do it to the other. This turns into a plus, and I end up with 8 over r minus 10 equals -4. Well, I want to get r minus 10 off the denominator, so I'm going to multiply this whole thing by r minus 10, which is going to cancel out. Excuse me. And then then I got to multiply this whole side by r minus 10. So we're going to distribute. And I'm going to have 8 equals negative 4r plus 40. Let's subtract 40 from each side. So we'll come over here. We get negative 32 equals negative 4r. Divide both sides by negative 4. Negative divided by negative is positive. 32 divided by 4 is 8. We know that 8 equals r. So pause it, write that down if you need to. Let's go. Hey, we got it. Not sure what was there. And this is our last problem today. It says the continental slope is an often steep oceanic landmass between the continental shelf and the oceanic crust near Cape Hatteras, North Carolina. The continental slope is especially steep at 75 meters from the shoreline of Cape Hatteras. The continental shelf is 65 meters below the ocean surface. At 125 meters from the shoreline, the ocean is 2,700 meters deep. What is the slope? Okay, so let's look at this. So we have 0.1 right here. What does it say? At 65 meters below the surface, or at 75 meters, so 75 meters from the shoreline. So 75 meters from the shoreline means we're going this way 75 meters. So 75 meters is my x. We're at a depth of 65 meters. But it also tells us so that's at 75 meters, at 125 meters from the shoreline. So this is 125 meters from the shoreline. Goodness gracious. We're at a depth of 2,700 meters. Boom. So what do we do? Pause it if you want to do it on your own. But essentially, we're just doing the formula, which says 2,700 minus 65 all over 125, right? Minus 75. So this is going to equal 2,600, 935. And that is all over 125, 50. So I'm going to get out my handy dandy calculator. And we're going to estimate the slope. What does it say to round it? Nope. So we're going to have 26. Oh my goodness, I did this wrong. Not 935. It's 2635. What the heck was I thinking? I just was looking at that going, something is wrong. 2635 divided by 50. And so that gets us slope. Let's go down. I got to get rid of all this. Of 52. Oh, I had it right down here. 52.7. Look at that. I can even show you. Look at that, my calculator. It said 52.7. Just so you know, I wasn't making it up down here. So we have a slope of 52.7. All right. That's how we use slope. With that said, we got to get going. Enjoy your math. Peace out.